Good evening, everyone. Today's session is on types of clustering. We will be discussing about the clustering methods and what are the application, what are the advantages and disadvantages of clustering. We know that like our clustering algorithms are unsupervised are used in unsupervised learning where we don't have the label data set. So we identify the patterns in the data and accordingly we cluster those data points into different groups. So like whenever we want to segregate the data points into different groups, there might be some patterns in the data. If there is no pattern in the data, we cannot have an AI in that, like we cannot apply anything to that, right? So first of all we find the patterns in the data. So here, like in this clustering technique, we will be using the first type of technique, like we have already discussed the k-means technique, and today we are going to discuss with the hierarchical clustering method. Right. So in hierarchical clustering methods, we have a hierarchy of clusters, we have a hierarchy of data points, and that basically that hierarchy tells you about in which cluster the data point is falling. Right. So here we are using a hierarchy decomposition of data based on group similarities. Like if the distance between the two data points are less or minimum, they might be uh, falling under the same cluster, right? So basically when we talk about hierarchical clustering, there are two top level methods for finding this hierarchy in hierarchical clusters. First is agglomerative clustering. Second is divisive clustering, right? So when we talk about agglomerative clustering, it is basically uses the bottom up approach. It uses the bottom up approach, and wherein the data from where we are going to start, each data point starts in its own cluster, and these clusters are then joined greedily by taking two most similar clusters, and then we are merging those data points into that particular cluster, right? Whereas in another type of clustering, that is divisive clustering, and that is another approach of hierarchical clustering, that is top down approach. So whenever we have top down approach, we will be using the divisive clustering, right? Wherein we start with all the data points and then we segregate into different clusters, right? So where all data points start in the same cluster. So we make like this. I will be showing you with number of examples. You can then use a parametric clustering algorithm like k-means to divide this cluster into two clusters. For each clusters, you further divide it down to two clusters until you hit the desired number of clusters, right? Now this could be my this is called dendrogram. Like it shows, this is called dendrogram. So dendrogram basically is a tool or is a graphical method to represent the hierarchy of clusters or the hierarchical clustering method, right? So I told you, when you have the bottom up approach, you will be using agglomerative method, and when you have top down approach, from top you are going to start, and from down it is going to end. So that means you are going to use the divisive clustering method, right? So this is one of the like whenever you are using, you are going to use the divisive or you are going to use the agglomerative clustering methods. Now let us take our dendrogram and let us understand how it makes the hierarchy of clusters. Right. So here we have agglomerative hierarchical clustering. Here, these are the data points, right? These are the data points which we have, and because it follows like how it segregates into, like suppose if these two data points like BC are coming under one cluster, right? And then we can say that like your DE points are coming under one cluster, and your F point is nearer to them, then you are clubbing and making it as a one cluster, right? Then you are segregating it with another cluster, like BC is not a part of DE. In the next step you are merging both the clusters like BC DE, and then at the end, because this is a separate point, this is not included in any of the clusters, then you combine this BC DE with your A data point, right? So basically they are this is the one method. Let us see how we make dendrograms, right? So hierarchical clustering technique can be visualized. So what is the method to visualize that hierarchical clustering is the dendrogram. So dendrogram is a T-like structure, like this would be your dendrogram. It looks like a tree-like structure, wherein you have all your data points, right? So it's a tree like diagram that records the sequence of all of merges or splits, right? A cluster at level I is the merger of its child cluster at level I minus 1. So this would be like how we make a dendrogram, right? So this would be my like, suppose I have made the dendrogram for it, and let us see how it clusters it. So you have two data points B and C. So what we have to do, we have to make a make 2 points and make the hierarchy. And again, these are the two nearest points, make another hierarchy of DE. Then we know that F is nearer to this cluster rather than this cluster, right? So F is now merged with D and E cluster. So that's why this is merged to, this F is merged to D and E cluster. And then we can say that again we have another points like B, C, D are more nearer to each other rather than A. So what we have done, we have merged all the points. Now we are going to merge the A point with our main cluster. This is how we make the dendrograms according to the graph that is given to us. So the graph says that, like, according to the graph we have to make the dendrograms. So here what we usually do is we make the simple nearest part, the nearest data point we find it, and then we merge those data points and make a cluster out of it. So initially, let us go through the algorithm part also. Initially, each data point is considered as an individual cluster, right? At each iteration, the similar clusters merge with other clusters until one cluster or clusters are formed. So like at the end, you may say there are different clusters that you have find according to the points, and then you make like this, and outer part then you make a one cluster that is containing all the points. This is our basic motive for deriving the for applying the agglomerative hierarchical clustering. So let us talk about the algorithm. Compute the proximity matrix. Let each data point be a cluster. So what we do is we make it like one data point would be one cluster, then another data point would be another cluster, and like suppose these are my 2 points and they are nearer to each other, so we make one cluster out of it, and then we merge this point into this cluster. So this is how it works basically. So merge the two closest clusters and update the proximity matrix until only one single cluster remains. So this process continues till you derive the single cluster, right? So let us learn about more about agglomerative hierarchical clustering. Before any clustering is performed, it is required to determine the proximity matrix containing the distance between each point using the distance method. So we will be finding the distance between both the data points. Both the data points, we are going to find the distance first of all. So then the matrix is updated to display the distance between each cluster. The following three methods differ in how the distance between each cluster is measured. There would be single linkage, that is minimum is used, complete linkage, maximum is used, average linkage, right? Let us start one by one. Single linkage, minimum is used, distance between the closest members of two clusters. Like suppose this would be my one cluster and these are my two data points, and they are the minimum distance between both the data members. right? Then we have complete linkage. Complete linkage where we find out the maximum part. So here what we find, the data point which has the minimum distance. So which has the maximum distance, that is somewhere around this. So this would be my maximum part, like when we find out the complete linkage. So distance between the members that are farthest apart in two clusters. So you have two clusters, right? Now here you will find the maximum distance between the two data points of two different clusters, right? And then another linkages would be your average method. It involves the average distance between each point in each cluster to every point in the other cluster. So what we are going to do, we are going to check out the distance between the data points, and we are calculating with the other clusters also, like how this data point is going to have the distance between this another. This would be, then this means you are relating between each data point from each cluster to every data point from other cluster, right? You have to combine it with uh, both the clusters, right? Then let us see the single linkage. Suppose you have 7, 10, 20, 28 and 35. So we would be finding like this. 7, 10, what will be my distance? It would be 3. 10, 20, what will be my distance? That would be 10. 20, 28, 28 minus 20 would be my 8. 35 minus 28, that would be my 7. Then again you make a combination of out of it, like you make the cluster out of it, right? So you have, this would be my minimum cluster like 7, 10, and then again you follow the same procedure. This would be your this thing. 10 minus 20 would be your 10, then 8, then 7, right? Then again take another part, take the another iteration out of it. Again 7, 10 is 20, 10, and 20, 28 would be your 8, right? Then you basically you merge the closest cluster. So here we find out the minimum distance, that is 3, so we combine these two. So here we are finding the 7 as the minimum distance, because in the single distance, in the single linkage, what we are going to do, we are going to use the minimum distance. So what we have done between the two, which is in this iteration, which is the minimum distance between the two data points, that is 7 and 10. So we have combined those data points into one cluster. So again in this part we have combined 7 because 28 and 35, because 7 is the minimum distance. Again next part, again in next part we have 8, so we combine these three into one part, and then totally all the clusters. So what would be my dendrogram for this particular linkage? That is 7, 10, right? And that would be my, then again your 20 to 35, right? And you can make any like through this step, like you can have the first step, that is 7, 10, then you have made another step 28 and 35, then you combined it with 20, and then the whole dendrogram will be made. So this is for single linkage. Now when we have complete linkage, we find out the maximum distance, right? We find out the maximum distance. So let us use that part also. So here we would be finding the distances now. So here we will be having 3, 10, 8 and 7, right? So what we have done, because it would be our the last method, like linkage method. So what we have done, we have taken 7, 10 as one group, and then 20 into another group, because we are combining directly with 10 and 3. That would be a 13, right? So it would be like it is nearest points, that's why we have not taken, we have taken it as 13. Now let us combine it with the maximum distance like 15. So your, then again it would be this thing 15, 13 and 15. So you have combined this 20 with the this part, and then you have taken the dendrogram out of it, that is 7, 10, then you combine it with 20, 28 and 35, you take it as a for 15, and then you combine it for the last cluster. So this is how you are going to find that part. Now let us say, using Euclidean distance method, let us see how the single link, like when we have the minimum distance, how we make that part. So you have different points, you have P1 point, you have, suppose this is my x-axis and this would be my y-axis. So 0.40, that would be my first point, and 0.5. So somewhere here 0.4 and some, yeah, this is my P1, this is my P2, P3. You plot all the points, right? You plot all the points. Then what you can do is, now you can find out the distance, right, using Euclidean distance method. So in Euclidean distance method, you find out the first part, like you are taking the 0.4 minus 0 to 2, and then because you have to take any of the, like take these 2 points and then find out the distance between them, right? 0.4 minus 0 to 2, 0.53 minus your 0.38. And then because Euclidean distance method talks about your this thing, x minus your another point whole square plus y minus b whole square, right? And you find out the distance, like this would be my 0.23 distance. So here P1, like for P1 to P2 would be your distance. So this is how you are going to calculate for all the data points, right? You have to find out the distance between all the data points. Find the pair with minimum distance from matrix. So here, which has the minimum distance from the matrix? It's 0.2, it's 0.15, it's 0.11. So this is the minimum distance that we have find from P3 to P6. So this would be my first cluster, right? So here, like update the distance. Now again you are going to update the distance and find the distance between other clusters. So you might be having, like there are different values, again you find the same position, you take two distances and minus it, and then you again derive this matrix, and you will be like, this would be my first cluster. Again the minimum distance between P3, P5 and P6 would be, like your minimum distance would be P2 and P5. So because this value is 0.14, right? So here, because in this point we are having 0.15, right? P3 and P6, it would be again 0.15. So here what we have done, this is in the next iteration, what we get is the minimum distance between P2 to P5. So again we have made one cluster out of it. So now we have updating the matrix, again finding, again applying the same formula, and now this would be my minimum distance, then that is 0.15. So what we have done in this part, we have taken the groups parts also, like these two groups are now falling into falling into one cluster, right? 3 6 and 2 5. So you have made one cluster like this. These are the two hierarchies we have made. First of all, we have find out the distance, they have the minimum distance. So we find this pair first and another pair, we have find this, and then we combine, we have merged both the pairs. So this is how we are deriving the dendrograms as well. So again in the next step we would be having another cluster, which is this one, which is having your point this thing also, right? So here what we have done, again we have clubbed it with another point, then that is P4, we have clubbed it with P4 point. So this cluster would be clubbed with the P4 part, right? So you might be having like this, right? So again this would be my dendrogram, we have added P4, and at the end what we have done, we have calculated the P1 also. Now the last final dendrogram would be like this. You have, first of all you have find two data points, right? Then again this would be my second step, then you have made the cluster like this. These are my two clusters that we have derived, then you combine, then you merge with P4, and at last what we have done, you have combined all the points with your P1. So once you have made this diagram, then you start making this one, or you can say that, like whenever you start with one step, you can make the first step. Then what we have done, we have done with the second step, then you combine both the hierarchies, right? And then you have taken the P4. So P4 is then added, and at last you have added the P1, right? So this is how, like, you have derived using agglomerative approach. Like, you start with the data points and you start from the bottom, right? So it basically talks about bottom to top, right? So what are the advantages of hierarchical clustering is no a priori information, nothing is required. You can start with any of the data points and apply the Euclidean distance method for deriving the distances, right? Easy to implement, gives the best result in some cases. Algorithm can never undo what you have done previously. Yes, this is one of the advantage. Yes, it requires the like, it's a time consuming method, and bigger you have the n square log n complexity, complexity, if we are going to calculate the complexity of this algorithm. Based on the distance metrics chosen for merging different algorithm can suffer one of the following: sensitivity to noise and outliers. Sometimes it happens like you may have some one or more outliers in your program. Breaking larger clusters. So yes, it is time consuming for breaking the larger clusters, and different difficulty handling different sized clusters and converge shapes. No objective function is directly minimized. Sometimes it is difficult to identify the correct number of clusters by the dendrogram. Yes, you cannot find like what are the number of clusters that we can have in a for the particular data points. We don't have that kind of thing also. Next type of clustering is density based clustering, right? In density based clustering, it is a partition method like your k-means, right? So it is again a partition method. Clustering and hierarchical clustering are suitable for finding the spherical shaped, right, or convex clusters. In other words, they work well for compact and well separated clusters. Moreover, they are severely affected by presence of noise and outliers, right? So for avoiding this, we have DB scan algorithm, right? Density based clustering algorithm. Let us see first of all the difference between the k-means and your density based. The figure shows that a dataset containing non-convex clusters and outliers noise. So you have some outliers also in the datasets. The plot above contains 5 clusters and outliers, 2 ovals clusters, 2 linear clusters, and 1 compact cluster. So you might be having number of things in this particular part, right, as a cluster and an as a outlier. Given such that k-means algorithm has difficulty for identifying these clusters with arbitrary shapes. Yes, it is would be very difficult to find out which one is the oval, which one is the linear, and how you are going to find out that this would be my linear graph, these are my 2 oval graph, these are my 2 linear graphs, and this is something like compact. So this is very difficult in that case. So the density based clustering comes into the picture with overcoming these difficulties, right? The basic idea behind that is clusters are dense regions in the data space separated by regions where lower object density. Our cluster is defined as the maximal set of density point discover clusters of arbitrary shapes. So you might be having different shapes. So density is basically is used to handle the outliers, is used to handle the noisy points. The goal is to identify the dense regions only, which can be measured by the number of objects close to a given point, right? So density based spatial clustering of applications with noise, it is the DB scan method, which is used for basically for density based clustering, right? So let us see what is that. There are two parameters of using this algorithm, right? First is epsilon, the radius of neighborhood around a point x. Minimum points is like when you require minimum number of neighbors within the epsilon radius. We usually take it as 3. Direct density reachable, a point A is directly density reachable from point B if it is a neighbor point or if it is a core point. Like suppose I am talking about this thing. This is my epsilon and it is my radius also. I would be having some a or b points, and I'm going to check out like this point, the distance with this, and the distance with it might be my core point, it might be my neighboring point, and if it, or it might be my like boundary point also, right? Something like this. If it is an outlier, it is outside the boundary, right? So density reachable, a point A is density reachable from B if there are set of core points leading to B and A. So if they are reachable, if they are reachable, 2 points, and if the density is connected, when we the density is connected, 2 points A and B are density connected if there are core points C such that AB are density reachable to C. So like this. So here we can say that this would be like, this would be my 1 point, right? And then we have taken it as epsilon, and this would be my, it might be possible there are some border points and there might be some outliers also which is not reachable to any of the cluster. So or it would be my noisy point, right? So in case of noisy point, what happens, like suppose I have used my epsilon, right? This would be my epsilon and it is taking the radius. Somewhere you are calculating the number of points. It could be on your boundary and it could be as an outlier. It could be a noise. So you find out the distance between the epsilon and the other points, and then you find out whether the point is core point, whether the point is neighboring point, or whether the point is your boundary point. But if it is a noisy point, it would be an outlier. So the noisy point are basically not within the radius of that particular data points, and it falls outside your boundary, right? So it basically goes into the denser regions. That's why we use this density based, uh, because here we are going to find out the data points which are actually the noisy points. So in k-means or in other clustering techniques, there is nothing, no technique is there to handle the noisy data points, right? Which are basically as your outliers which are not, which are exceptions basically, right? So here this db scan is basically meant for dealing with the noisy data points only. So if you have noisy or outliers in your data set, it is best method to use the gbscan clustering technique, right? So and it is efficient also, like it is going to handle the uh, outliers also, right, from your data set. So it is, yes, it is going to handle that part also, right? So hope you have understood what are like what is hierarchical clustering, what is agglomerative clustering, and what is divisive clustering. Apart from hierarchical clustering, hope you have understood the concept of density based clustering also, because these are the clustering techniques which are widely used in our like whenever we want to segregate the data points. And the most important thing is what we have learned today is dendrograms, using a numerical, using one example, like how you are going to deal the with the data points and draw the dendrogram for the same, right? Hope you understood the session and hope you like the session. Thank you.